Namaste, welcome to our guidance classes for the Group 1 services conducted by the Tspsc. In this sessions, we are going to discuss about the science and technology. As you know that science and technology is one of the most important area for the prelims as well as mains also. Among science and technology, we have a basics of physics is one of the major chapter. In this, we are going to discuss about the various branches of physics and its basic principles and laws. Okay. So, we have various kinds of forces, energies. So, we discussed already fluid dynamics, thermodynamics, mechanics, now electricity. Now, we are shifting to the next area, that is called as magnetism. As you know it, magnetism, the motion of electrical charges creates current and generates an electromagnetic force, resulting in magnetism. Like charges, magnet consists of two opposite components. These components, called poles, are also similar to charges in that like poles repel while opposite attracts. Each magnet has a north and south pole. Earth also has magnetic poles, though their location is not quite the same as the more popular geographic north and south poles. Scientists think that Earth is swirling metallic core creates the planet's magnetic field, the making Earth giant magnet. And we will feel that our Earth is a big magnet. Generally, we will call it as alnico, A-L-N-I-C-O. Alnico, generally aluminum, nickel and cobalt. These combination will form them. There are two kinds of magnets, as permanent magnets and temporary magnets, and we have electromagnets also there. Every magnet has two poles, we call it as north pole and south pole. Clear? So, now we are, so when you consider, this is called a bar magnet, this is a bar magnet. We have so this is a north pole, for example, say this is a south pole. The magnetic force of attraction is concentrated is more at poles and minimum at the center. The magnetic line of forces starts from north pole to south pole. The importance of these magnetic line of forces, so they like a smooth curves, they won't intersect each other. So, that is a very, very important. So, this magnet, and you know that, and the force between, you take it as one object here. So, it attracts, and a very important thing is like poles repel and unlike poles, like poles will be repel and unlike pole will be, means between north and north there is a repel force, between north and south there is an attractive force is there. Clear? So, this is a very, very important. And as you know that, so we have for each and every molecule, the reason is, so when you take it as, so when you take a magnet and non-magnet, all our substances have the dipoles. If they are arranged in a regular order, then it exhibits a magnetism, a magnetic force of attraction. But if they are not arranged in order, so it will lose their magnetic forces. Clear? So, that is and the very important thing is the force is simply we call it as mu naught by 4 pi and say m1 m2 by d square. This is the force of attraction between two, that is mu naught by 4 pi m1 m2 by d square. Here for mu naught is called permeability. Mu naught is called permeability, and so this and the unit for the permeability is Henry per meter. Henry per meter. So, this is a very important thing, you have to know this about this poles here. Okay. When you come into this two magnets, when you take it as any two magnets, just now I said F is equal to mu naught by 4 pi and m1 m2 by r square, and of course here you know that units will be here and Weber, and the units for the pole strength, is Weber. Unit for the pole strength is called Weber. Clear? Okay. Now come to the very important thing is optics. So, optics means eyeglasses, contact lenses, microscopes, move projectors, cameras and more all exist because of the physics of light or optics. These innovations harness the principles of refraction are the angles at which light bends when entering into a different material. For example, glass lenses similar to the lens of an eye use refraction to the focus and magnify the images. The refraction also creates strange images of a disproportionality, a square to lower half when a person stands waist deep in a pool. Light travels slower in water, so the human eye gazing at the pool from the above perceives objects in water as closer than the actually they are. Okay. So, now we will discuss about the light one. And light, for example, see means light have 5 properties, that is called simply called as a reflection, refraction, dispersion, diffraction, polarization and total internal reflection. These are the different properties of light. When a light ray, when you take it as a light ray incident on a surface, means this is called angle of incidence. When you draw a normal to it, okay, this is called angle of reflection. So, here I is equal to R. Angle of reflection is equal to angle of incidence. So, this and the angle made by with the normal drawn at the point angle of incident and angle of reflection both will be same. We are seeing our image because of reflection of light. Okay. So, there are two kinds of lights, there are two kinds of things here. One is called what you call it as some objects allows the light through it and some objects will not allow the light. If you take it as some water in it, a glass of water, when you keep a spoon inside it, so when you observe it from the top, so it seems to be little bit of bend. The reason is reflection. When the light ray travels from what the lighter media to denser media, it bends. Then you are observing that image will be bends. That is called refraction. Okay. When the light ray incident on a prism, okay, it reflected, of course, diffracted into 7 colors like it as Vibzy arc, violet, indigo, blue, green, yellow, orange and red. So, in this process is called diffraction simply, and of course, in the rainbow will be forms. And as you know that the total internal reflection, due to total internal reflection, so we are able to see the another, and of course, the fiber optics based on total internal reflection concept only. The velocity of the light is 3 into 10 power 8 meter per second. So, this is the velocity of light, and as you know that actually there are two theories. One is called Newton-Korpuscular theory and Huygens theory. There means according to the Newton's theory, it travels like it travels in a linear path as a particles, whereas the Huygens theory, light travels in a wave theory. Huygens wave theory is there. So, there is a dual theory for this light, Newton's corpuscular theory and Huygens wave theory is there. So, one of the important area in this particular thing here, when you take it as lenses, we have a convex lens. Take it as a convex lens. This is a convex lens. Okay. When so convex lens is said to be convergent lens, and concave lens is said to be divergent lens. So, why convex lens is said to be convergent lens? Why concave? This is a very, very important. The important thing is when you consider a prism, when the light ray incident on it, so it bends towards its base. When the light ray incident on a prism, so it bends towards its base. So, this is a very important thing here. So, when you take it as a convex lens, we can split the convex lens into some parts. When you observe this, the means here, so the middle one is exactly as a glass prism. When the light ray is incident on this part, it travels like there is no kind of deviation. But when you see above this glass slab, all the bases of the prisms, all are prisms, correct? All are downwards. The bases of the prisms are downwards. When the light ray incident on this prism, as per the property of the light, it bends towards the base, means like this. When the light ray incident on this here, it bends towards it. When light ray incident and bends towards it. So, here when you consider these parts, the basis of this parts is in upward direction. Means again when the light ray incident on it, it bends towards it. It bends towards it and it bends towards the point. Means all light rays is converged at one point. For that reason, convex lens is said to be convergent lens. We will get the real image. By using a convex lens, we will get a real image. It is called convergent lens. When you consider this concave lens, so when you divide in the same manner, the middle one is a glass slab as you know it. When the light ray incident on it, it travels like here. When you see above the glass slab, the base is in upward direction. When the light ray incident on it, it bends towards the base, means like, correct? Here it is in downwards, it bends towards like, means when you extend these lines here, correct? So, means here, so the light rays are diverged. So, here the light rays are converged, means it forms an image. So, here it does not forms here virtual image, means we can't catch this image on screen. So, convex, this is called is a divergent lens. It is a concave lens. So, this is a very important. When you want to learn the concepts, you have to understand the basic concept. Otherwise, simply if you by heart convex lens is a convergent lens and concave lens is a divergent lens, there is no use. So, why it is convex, why is convergent, why is divergent. That basic concept is a very important. And the very important thing is, so when you take a prism, the light ray incident on it, correct, and it bends towards it and light. Okay. So this one means when you extend this line, this is called angle of deviation. Say this is angle of prism. This is angle of deviation, angle of prism. Here there is a Snell's law. Mu is equal to sin I by sin R. Mu is equal to sin I by sin R. This is called Snell's law. So here I is angle of incidence and R is angle of refraction. Clear? Okay. So mu equal to sin I by sin R, and here you can say mu is equal to sin of A plus D by 2 by sin A by 2. A plus D by 2 by sin A by 2. Here A is the angle of prism and D is the angle of deviation. And sometimes mu is equal to, you can say 1 by sin C. C is called critical angle. Mu equal to 1 by sin C, and C is called a critical angle. This is also a very important. And the very important thing here, so if you two mirrors, when you take it as a two mirrors, this is one mirror and this is another mirror, the number of images formed between these two mirrors is 360 by n minus 1. Okay, how many images here? Yeah. And if you say that, if what you call it as a if you say UVF, this one is F is a focal length and V is of course we call it as the distance of the image from the foci and from the lens, and U is the distance of the object. Then the relation between these three is 1 by F is equal to 1 by U plus 1 by V. This is called lens making formula. 1 by F is equal to 1 by U plus 1 by V. This is very important. And your radius of curvature is equal to 2 times of the focal length. This also one more concept. Clear? So like we have various parts. Now we are coming to the different principles. That is Archimedes principle. This is a very important. The principles was discovered in 3rd century BC by the Greek mathematician Archimedes. It states that when a body is partially or totally immersed in a fluid, it experiences an upward thrust equal to the weight of the fluid displayed by that is its apparent loss of weight is equal to the weight of liquid is displaced. This is called Archimedes principle. So maybe means here when a object is immersed in a liquid, how much volume, how much quantity of the liquid is is just it will displace that amount of that quantity, the volume of that a liquid is equal to the volume of the object. That is the concept. This is the principle of Archimedes. As you know it, there is a lot. So actually there is a historical story also there. So means here at the time only he used the one word called as eureka, means I find. So and on that there is a one teaching strategy also there, that is called heuristic method. Heuristic method based on this Archimedes principle only. Means here Archimedes principle is discovered by the Archimedes by his name only, and when a body is partially or totally immersed in a fluid, it experiences an upward thrust equal to the weight of the fluid displaced by it, and apparent loss of weight is equal to the weight of liquid displaced. This is called Archimedes principle. And the next one is second law is called Avogadro law. Avogadro law in 1811, it was discovered by an Italian scientist, Andreas Avogadro. This law states that equal volume of all gases under the same conditions of temperature and pressure, it contains equal number of molecules. We will use one word called as STP, standard temperature and pressure, and we will call it as one more NTP also, normal temperature and pressure. Here at standard temperature and pressure, a gas of 1 molar contains 6.023 into 10⁻23 molecules. This one is called Avogadro number, and this is called Avogadro law also. According to the Avogadro law, equal volume of all gases under the same conditions of the temperature and pressure, under the same conditions of temperature and pressure means an STP, standard temperature and pressure. So, 1 molar gas contains 6.023 into 10⁻23 molecules. So, all equal volume, all gases have the same number of, equal number of molecules. This is called Avogadro law. Okay. Now, we are going to see the next one, Ohm's law. So, it states that the current passing through a conductor between 2 points is directly proportional to the potential difference across the 2 points, provided the physical state and temperature etc. of the conductor does not change. At constant temperature between the two ends of the conductor, the potential difference is directly proportional to the current passing through it. Means V is proportional to I. V is the potential difference by the two ends of the conductor, and I is the current flowing through it. As you can say is equal to V equal to Ri, R is here the proportional constant, and this one is called the resistance. So, V is equal to Ri. The condition is at constant temperature. We will draw a triangle also, that is V and say Ri. We can say cross here, means V is equal to Ri, or V is equal to R is equal to V by I, or I is equal to V by I. From this you can write it V equal to Ri, R is equal to V by I is equal to V by R. Clear? Like you can write it. So, the substances which satisfies the Ohm's law is called ohmic conductors, which does not satisfy the Ohm's law is non-ohmic conductors. So, this is a Ohm's law. Clear? So, means simply the potential difference is directly proportional to the current passing through it. Now, next one, the relation between the Newton's laws. So, the first law represents the inertia. As you know, until and unless the external force acting on it, the body will continue the same position. Means when it in constant, speed motion, it is in motion only. When it is at rest, it is still at rest only. Clear? That is called inertia. This first law states the moment of inertia. Simply it states the law of inertia. The second law. Second law says that F is equal to ma. Correct? Okay. Means here the rate of change of momentum is called force. So, F is equal to ma. Okay. And the next one, the third law, as you know that the third law says that for every action there will be equal and opposite reaction. That's a relation. So, this is a relation between first law and second law, means special case here, and for all matters it will be same here. So, these are the three different laws for Newton's. Okay. Now, moving to the next one. Coulomb's law. The force between the two electrical charges reduces to a quarter of its former value when the distance between them is doubled. The SI unit of electrical charge is Coulomb, is named after Charles Augustin de Coulomb, who established the law. So, simply you can say the force between two F is equal to 1 by 4 pi epsilon naught Q1 Q2 by d square. Here epsilon naught we call it as permittivity, and Q1 Q2 is the charges here, and d is the distance between the charges, the force between these two, and the unit for charge is Coulomb. So, the force between two electrical charges Q1 and Q2. So, here as distance distance increases, when the distance doubles, the force between the charges will becomes 1/4. So, that is a Coulomb's law, or you can say F is equal to 1 by 4 pi epsilon naught Q1 Q2 by d square. Clear? Okay. Now, the next one, the Stephen's law. Stephen's law is 1835 to 1883. The total energy is radiated from a black body is equal to the 4th power of its absolute temperature. The Stephen's law states that the total energy is radiated from a black body is equal to the 4th power of its absolute temperature. So, here if you say the energy is E radiated from black body is equal to the 4th power of its absolute temperature, means is absolute temperature say is T, then T to the power of 4. This is called the Stephen's law. And one more important law is called Pascal's law. This Pascal's law means 1623 and 1662. The Pascal, when pressure is applied to a fluid, the pressure changes is transmitted to every part of the fluid without loss. Hydraulic machines like the hydraulic press work on this principle. Atmospheric pressure decreases with the increase of its height. The SI unit of pressure is Pascal, as you know it, which is named after Pascal, who established this law. So, this is a very important thing here. When the pressure is applied to a fluid, the pressure changes is transmitted to every part of the fluid without loss. Mostly these hydraulic machines are working on these principles only, and like the hydraulic press works on this pressure. Okay. The units for the pressure is Pascal. So, this one we call it as a Pascal law. The last one is we can have to discuss as the Hooke's law. As you know that this law states that the extension of a spring is proportional to the tense stretching, and doubling of the tension results doubling of the amount of stress. As see here means that simply is directly proportional. As the force is increasing, so means the extension of the spring is also increased. As the tense increases, the also is means here F is proportional to L. So, like it will says the Hooke's law is saying, so if L is more, then it has more elasticity, and when it is less, we have more plasticity. That is based on the Hooke's elastic material depends on the Hooke's law, which satisfies this one about. These are the various things, different laws. We have some more laws in the physics, we have to discuss all these things in the next session so all these things are you have to remember and practice these things. Definitely it helps to understand the basics basic concept of physics. Clear? Here already you learned that Ohm's law, Ohm's law is very important, as you know that V is equal to Ri, and Coulomb's law and universal gravitational law, universal gravitational law also very important, as you know that F is proportional to m1 m2, F is proportional to 1 by r square, and F is equal to m1 m2 by r square, of course G m1 m2 by r square. All these laws you have to practice. Definitely it gives a clear concept to all of you. Thank you.